All right, so recording started. So welcome everyone to the discussion session for the homework Linear Relations and System of Equations. So this homework is due Friday night. So for this homework, I would say that it's very important that you start thinking about the problems first with a paper and a pen, because I think it's one of the first homework when you really have to think about what you want to code in MATLAB and how you want to define the variables, etc. before really coding. So please think all the time with a paper and a pen. So in this homework, you are going to solve systems of linear equations. So I'm just going to quickly remind you what the system of linear equations is and how you can handle them in MATLAB. So a system of linear equations can be represented in the form A times x equals b, where x is the vector of unknown, and A is a n by n matrix that you know, and B is a n by 1 vector that you know. So this is the kind of equation that you will be seeing a lot throughout the homework. So you saw in the video lectures that there are different cases for there are different types of solutions. So it might be possible that there is no solution, or there is one solution, and if there is one solution, so there can be one unique solution, or that there can be an infinite number of solutions. So remember that if a unique solutions exist, then in MATLAB, if you type x equal a backslash b, so basically a backslash b, this is the command with which MATLAB resolves the system of equation. Okay, and so this gives you the vector of unknown x. And otherwise, if there is either zero solution or an infinite number of solutions, then MATLAB raises an error. So keep in mind this throughout the homework. This will help you a lot. Okay, so let's move on to the first exercise. So in exercise 1, it's kind of a biological problem. So you have a population. You have three populations: a population of eggs, a population of larvae, and a population of adults. So each number of individuals in the population is given by the variables E of t for the number of eggs, L of t for larvae, and A of t for adults. And there are rules dictating how the different number of people in the population evolve. So these are the rules given at the top of page 2, right? E of t plus 1, so the number of eggs at time t plus 1 is equal to 45 times the number of adults at time t, etc., etc. So for question 1a, you want to write these three equations in the form that I talked about in the introduction. So in the form a times x equals b, so where so you have to give the matrix form of A. So for that, I suggest you write the equations in this form. So something times E of t plus something times L of t plus something times A of t is equal to E at times t plus 1. And same thing for L at times t plus 1. Same thing for A at time t plus 1. And then the matrix A will be exactly corresponding to the dots in the right order. So the element of the first row, first column of A will be the first three dots. So the three dots on the first line, the first ones. Then the element in the second column, first line, will be the three dots at the first line before L of t, etc. And you can convince yourself that if you multiply this matrix A by the vector x of t, so defined by, it's a 3 by 1 vector, E of t, L of t, A of t, then you will have exactly the results in the expression, in the 3-line expression at the top of page 2. So this is how you are going to find the matrix A. All right, so for 1b, you have to use the matrix A that you just defined to compute the number of individuals in each population throughout time. So, and to do that, you know the initial number of individuals in each population. So you know that E at time 0, so E is the number of eggs at time 0, it is 2000, the number of larvae is 100, and the number of adults is 25. So, and basically you'll have to calculate the vector for each time step. And for that, of course, you'll have to use the matrix A. So in MATLAB, the first thing I suggest to do is that you create the matrix where you will store the data. So you create a matrix with 3 lines, and the lines will correspond. So the first line will correspond to the number of eggs at time t. The second line will correspond to the number of larvae, and the third line will correspond to the number of adults. And the different columns will correspond to the times. So you will have 51 columns because you start at time 0, where you can already define, so you can already define this first column. And after that, you will be filling the column one by one. All right, so the second step you do is that you can initialize the first column of the matrix because you know the initial populations. So you know that the first column, data column, comma 1, this is the first column, and it contains the initial population at time 0. So be careful, there is a difference of 1 between time and the number of the column, because time 0 corresponds to column 1. So don't be careful to the confusions here. The second column will correspond to time 1, etc., etc. All right, so once that you filled the first column, so corresponding to time 0, the thing that you can do is looping over the different columns, so looping over t. And in each loop, you will calculate the new population at time t. So data, the column t+1 of data is the population at time t, and data of t is the population at time t-1. Well, I guess, so that depends. That depends of t, right? You can write, for example, for t equals 1 to 50, and so in the first loop your t will be equal to 1, and the data, so data t+1 will correspond to the second column, and this will be the population at time t+1. All right, so for that also remember that the star operator in MATLAB is the operator for matrix multiplication. And you can use also A that's defined in question 1a to compute x t+1, which is equal to A times x of t. And then once you fill the array, you can easily compute the total population. So the total population is basically the sum over the columns. So you sum the number of individuals in each column, and this will give you the size of the population for every time t. And then the last thing you have to do is so plot your results. So for that, remember that so you have to plot one plot with 4 subplots. So you can use the subplot command. Remember, it has 3 input arguments, m, n, and p. So m and n stand for the number of rows and columns for your subplot, and p correspond to the index in the array, so the index you want to fill with the plots. So you'll have to use the subplot command, then plot what you want to plot, and then I suggest you add a title so that it's clear which plots refer to which population. Alright, so that was it for question 1b. And for question 1c, so the question is kind of vague. It is not stated what exactly you have to give for this question. So I suggest you compute exactly the same thing as in 1b, but this time changing one entry of A, right? So changing 45 to 44. And I suggest you draw the plots, you do the plot, and then you see the difference, and you comment that. All right. So there is a question on the autograder. I don't know when it will be available, but probably soon. But I cannot tell you exactly. All right, so let's move on to exercise 2. So for this exercise 2, it's really critical that you first keep thinking deeply about what you want to do, because I don't know how familiar you are with the linear algebra, but it took me like maybe 5 minutes to know exactly what I want to do, so it's not straightforward. So in exercise 2, you are asked to write a function. So it's the function average array. So this function takes as input 4×6 matrix M, where you have numbers that are already filled at the exterior, at the boundaries of this array. So first line, first column, last column. And you should not pay attention to what is inside at the interior of the matrix. And you are asked to fill the interior of this matrix. And you know that so for each entry of the matrix M, each entry is the mean of the entry above, below, on the left, and on the right. So basically, there are 8 unknowns, which are the entry 2 and 2 of M, second line, third column, second line, fourth column, second line, fifth column. So the second line, column 2 to 4, and the third line, column 2 to 4. So these are your 8 unknowns. And you also know that you will have 8 equations, because you can write that, for example, the second row, second column of N will be the mean, so 1/4 of first row, second column, third row, second column, and second row, first column, second row, third column. So for each entry, you will have 1 linear equations, and because you have 8 unknowns, you will have 8 linear equations. So this is a linear system. All right, so now we want to write it in the form matrix A. So this matrix will be 8×8. Matrix A times X, where X are the unknowns, equals B, where B is a vector that we have to compute. And we know that if we know A and if we know B, we can ask MATLAB to compute X. So X is the vector of unknowns. So it's 8×1 vector having all the unknowns. A is an 8×8 matrix, and we'll see how to compute the values in the matrix. And B is an 8x1 vector, and I'll explain to you how we can find the coefficients in A and B. All right, so for that, so this is all with. You will have to do that before writing anything in MATLAB, right? This is all with paper and pen. So the first thing is that you begin to write the 8 equations corresponding to the 8 unknowns. So to make your life easier, I suggest that you write that instead of writing that m, for example, m second row second column is equal to 1/4 of first row second column, etc., etc. So 1/4 of the sum of all the neighbors. I suggest you write that 4 times the second row second entry of m is equal to the sum of the neighbors. It will just make your life easier. Instead of having fractions everywhere, you'll just have integers. All right, so here I wrote the equation for the second row second column entry of m. So 4 times second row second entry of m is equal to m first row second column plus m third row second column plus m second row first column plus m second row third column. So you will, I just wrote the first equation, but you'll have 7 other equations like that. All right, and once that you wrote all these equations, I suggest that you rewrite these 8 equations. So there will be a lot of equations everywhere on your paper, but you rewrite these same equations, this time by writing your unknowns on the left-hand side of the equal sign and writing the entry you know on the right-hand side of the equal sign. So for my first equation here, I don't know the second row second entry, so I keep that on the left. And I know m12, so I keep that on the right side of the equal sign. I don't know the third row second column entry, so I switch that to the left of my equal sign. I know second row first column entry, so I keep that on the right hand side, and I switch the m second row third column to the left hand side of my equal. All right, so you'll have 8 lines like that, so 7 other equations. And then the last thing I suggest you do is that you rewrite once more the system of equations, this time by explicitly writing all the entries in the unknown vector. So by that I mean that on the left hand side of your equal sign, I suggest you write all of the entries of m that you don't know. So for my first equation, this will be 4 times m22. Then I don't know. So the next element, if in the unknown vector x is m23, and this comes with a -1, right? Because in the previous equation we had minus m23. Then the third element in my x vector, so in my vector of unknown elements, is 24, m24, and m24 doesn't appear in the equation just above, so it comes with a 0, etc., etc. So with that, you'll have 8 equations, and in each equation you'll have you are going to be additioning 8 elements, and it will be easier to define the matrix A and B. So the 8x8 matrix A is going to correspond to the numbers in front of the m coefficients, and the 8x1 vector B is going to correspond to the numbers that you have on the right hand side of your equals. All right, so I think it will be clearer when you'll be trying to do that. So with these steps, you will be able to express the matrix A and express the vector B. So now we know that we can ask MATLAB to compute for us the vector X. All right, so let's move on to the second step here of this exercise. So the second step is in MATLAB now. We are asked to write the function D that is equal to, so it is called average array of M. So the first step in your function is that you are going to define the matrix A and the vector B. And you are going for that to use the results of your of what you computed in the first part when you work with paper and pen. So yeah, in the first part we know exactly what A and B are, so just write that. Then second step is to use the backslash operator in MATLAB to resolve the system of linear equations, and this will give you directly X. And remember that X is your vector of unknowns, so it's M22, M23, M24, M25, M32, M33, M34, M35. So by using the backslash operator, you will know all these entries, and the last thing you have to do is fill the matrix M with the corresponding values of X, and this will be your output argument. All right, so good luck with this exercise. It's be patient. You'll have to write a lot of equations, but once you know what you want MATLAB to compute, the code is not complicated to write. The most complicated part is the first part when you have to think with a paper and pen. All right, so let's move on to exercise 3. So exercise 3 is the following of what was presented in the video. So it's the truss problem. So you have a physical system. It's exactly the same as the one given in the video, as the one presented in the video. So watch or rewatch the video if you don't know how to get started, or even if you know, because it will refresh your mind with the system of linear equations that you have to use. The physical system is exactly the same, so really there is nothing new. You don't have to be very good at physics to do that, because the linear system is explicitly given to you in the video, and I'm giving you exactly the time where it was given. So at minute 10:56 seconds, you have the linear system is expressed. So just go there and you will start from here. Pay attention, there is one difference. There is now a force px that is acting in the horizontal direction. So you'll have to modify slightly the system of linear equations that is given to you in the video. You will have to add on the right hand side of the second last equation this force px. So in this problem, once again, we have a system of linear equations. We have 6 unknowns that are the forces that are acting. So the forces T1 to T6, and we have 6 equations. So you'll see that in the video the matrix A and B are already defined. So A is a 6x6 matrix containing sines and cosines and zeros. T is the 6x1 vector of unknowns. So we want MATLAB, we want the help of MATLAB to compute the T, and B is the vector corresponding to the right-hand side of the equals. So you'll see that it's equal to 0, 0, 0, p of x, and p of z. Alright, so we have our system of equations. We have A, we have B, and now we want to compute T. So in MATLAB, in your function, define the 6x6 matrix A and define the 6x1 vector T, and then you'll be able to directly compute the vector T, the vector of unknowns. It is expressed as a function of the matrix A and the vector B, and you can use the backslash operator to compute that. All right, so let's move on to the last exercise now. So in the last exercise, you have to write a function that's called findPoly, and this function takes as arguments two n×1 vectors corresponding to the coordinates of n points in the xy plane. And in this function, you have to find the coefficients of the polynomial that passes through all the points. So in this problem, you have n points, b1 to bn. So each point is characterized by the coordinates x1, y1, and the point bn up to bn, where bn is characterized by the coordinates xn, yn. So you will see, or maybe you have already seen, or you will see that there is a very nice property that there is one and only one polynomial of degree n-1 or smaller that passes through all the points. So this is a very nice mathematical property. I don't know if you're familiar with it, but you can take it as granted. And what we want to do in this exercise is find the coefficients of this polynomial. So we can express this polynomial as stated in the homework. So p of x is defined as a coefficient a n-1 multiplied by x raised to the power n-1 plus a n-2 times x raised to the power n-2, etc., until a0 multiplied by x to the power n-n, and x to the power n-n is equal to x to the power 0, and this is 1. So that's why here a0 is the constant part of the polynomial. So the purpose of this exercise is to find the coefficients of this polynomial. So these are our unknowns, and there are n of them. So a of n-1, a of n-2, etc., until a of 0. So we know that this polynomial passes through all the points that are given by the coordinates x val and y val. So we know that the expression of the polynomial p of x holds for all the points. So once again, we are going to write a system of equations, and so p of x is the image of x by the function, the polynomial p. So this corresponds to the y value, the y coordinate of your point. And in p of x, x corresponds to the x coordinate of your point, right? So for the first point, we have that y of 1 is equal to a n-1 times x1 to the power n-1 plus a n-2 x1 to the power n-2, etc., until a0. So this is the equation that I wrote for you, like the equation that I wrote for you at the bottom of the discussion notes. But to make your life easier, I wrote it in the way you are familiar with. So I wrote the things that we know. So the y1 until yn, I wrote them on the right-hand side of the equation of the equal. So this is going to be the vector that we know. And I wrote the coefficients in front of the unknowns. So for us here, the coefficients will be x1 to the n-1, x1 to the n-2, etc. And also x2 to the n-1, x2 to the n-2, etc. So the power of x's here will be the coefficients that we'll have to use in the matrix. So let's be more precise about that. So the n equations that you have like that. So it's a linear system of n equations with n unknowns. So your unknowns are a n-1, a n-2 until a0. So you can write this system of equations in the form matrix B times vector A equals vector Y, where B is a n by n matrix and it corresponds to the coefficients that are in front of your unknowns. So remember that the unknowns are a n-1 to a0. And given the expression that you have in the two equations above, B contains the powers of x1 and xn. So the matrix B, the 1-1 entry of matrix B will be x1 to the n-1. The 1-2 entry of matrix B will be x1 to the n-2, etc. And the 2-1 entry of B will be x2 to the n-1. All right, so, and y is the vector corresponding to the right-hand side of the equal, so it's the vector y1 to the yn. y1 to yn, sorry. All right, so we know what b is, we know what y is, so we can now compute the vector of unknowns equation A. So we know how to do it, or MATLAB knows how to do it. So in MATLAB now you have to define the function polynomial, find poly, sorry, which take two arguments, the n by 1 vector of coordinates of x coordinates xval and the n by 1 vector of y coordinates yval, and you want to return the n by 1 vector in the variable poly, which is containing the coefficients a n-1 to the a n-2, etc. until a0, and this is the unknowns in the that I talked about in the first paper and pen. All right, so in MATLAB, the first thing to do is to define b and y. So thanks to the first step, you know now exactly what b and y are. So B is a n by n matrix. So I suggest here that you initialize it to be with the function zeros. So B is equal to zeros and then size n and n, where n, of course, is the length of the xval n by 1 array. And then to fill the matrix B, I suggest you look over the columns and use the function power. So remember that each column of B is corresponding to the elements of xval raised to some exponents. So here the function power will be helpful for you to fill the columns of B one by one. And remember that y is the yval vector. All right, and so once you have that, the second step is to compute the poly. variable, so the output of your function. So we know b, we know y, we know y val. I mean, so it's the y that I talked about in the paper and pen section. So you can compute the poly variable, the poly n by 1 array, by using the backslash operator. So poly will be b backslash y. All right, so this is the end of the discussion session for this homework. So I hope this will help you get started with the problems. Are there any quick questions here before I stop the recording? I guess not. So yeah, so this is the end of it. I'll stop the recording. I have a session today from 4 to 6. So you're welcome to come if you have other questions, and good luck with the assignments.